Okay, welcome back. I have a new whiteboard now. I like this one way better. It's way nicer. And watch this. You can actually read when I'm typing. Isn't that nice? Okay, so this is going to be the first physics video, and it's going to be about Sir Isaac Newton. And can I make it any bigger? Size. Yes, like that. Sir Isaac Newton. Okay, no. Let's see. Still getting to know. Okay, yeah. Sir Isaac Newton. So, you may have heard of him. And he was sitting under his tree here. Sitting under the tree. And, there's an apple right here. And, he was just sitting here, lying there thinking. And then, the apple fell down. And his head, he's like, ooh, gravity made it do that. Yay. That's the story that you probably all heard. Okay, clear. Okay, I'll just clear it myself. So that's probably the story you've heard. And, well, it kind of happened like that, but, it happened, but not entirely. So, before I get into what gravity is, there's a couple things you need to know. The 3 laws of motion. Dun, dun, dun. So, oh my god. So, 3 laws of motion. So, let's start off with law 1. Any object in motion will stay in motion unless it is acted upon by an outside force. That probably makes absolutely no sense. So, the first thing I'd say is, so let's say you have something like an apple, and it's falling, and it's falling, and it's going to keep falling forever until it hit his head. It stopped because it hit his head. That's an outside force. The force isn't coming from the apple. So, the friction in the air caused the apple to slow down. So, it would keep falling and falling and falling and falling and falling until it hit something. Because it can no longer move. If you roll a bowling ball, the only reason it's stopping is because of friction on the ground. And yeah, so if you had something in a vacuum, it would never stop moving. It would always be moving no matter what. So, the second one. The more mass an object has, the more force required to move the object. And this is also seen as F is equal to ma. So, the force required to move it is equal to mass times the acceleration, which on Earth is 9.81 meters a second. So, let's say you have a mass of 5 kilograms, and the acceleration is 9.81, so the force required to move it would be roughly 49.05 newtons, which is the unit of force. And finally, the last one, what is the third law of motion? What? How do I not know this? Oh, yes, of course. it states, for every action, there is an equal and opposite reaction. That probably doesn't make any sense. And understandably so, because I don't really understand it yet. So, the first two make sense. 3, so let's say you high five someone. So, an equal reaction. Okay, that's a terrible example. Okay, let's say you have a pulley. You have some string on a pulley with a bucket attached to one side, and you start pulling the rope. And so, the equal reaction is the rope getting pulled down. The opposite reaction is the bucket getting pulled up. Kind of makes sense, but not really. Okay, so you have the 3 laws of motion. And let me make these a little bit smaller. Okay, I'll just delete them. So you have the 3 laws of motion. And you have, kind of how gravity was discovered. But you're like, okay, well, what's that 9.81 figure? So it's really 9.81 meters a second squared. So 9.81 meters a second squared. So this is the speed that gravity affects on everything. So let's say you have... no, that's not what I want. So let's say you have a circle. Let's pretend you have a bowling ball, and you drop it, and it starts going down. But then you have a feather, and you drop it. Gravity is acting on these with the same force. It's just with the feather, the air is able to lift it up more, so it slows it down. With the bowling ball, however, the air can't lift that up, so it just falls straight down. And so that is what 9.81 meters a second squared means. Everything falls at the same speed. It's just outside forces change it. So 9.81 meters a second squared. So everything moves at the same speed. Great. And you got the 3 laws of motion. Great. You know who Isaac Newton is? Great. Okay. Why did I need to know all this? Well, that's a good question. Well, in science, you're going to need this. But, so, the reason you need it? Science. Science. And, well, physics, really, but... Wait, let me put it on. Science and physics. That is what this video is all about. Science and physics. Keep that in mind. The point isn't to know this because you need to know it. The point is to know it. But these do have some actual applications. See, we would know that, because now we can calculate the velocity, terminal velocity, which is the fastest speed something will reach. The height that it was dropped from, if we have the time that it took for it to fall. There's a couple of these equations. So, V is equal to UT plus AT. Yes. Velocity is equal to the starting velocity times time, times the time that it took to fall, plus the acceleration, so 9.81 meters, so 9.81, times the time. So let's plug in some numbers. So we have V is equal to, so most likely your starting velocity is going to be 0. If you drop something, the starting velocity is 0 because it's not moving. So 0 times, we'll say it takes 5 seconds to, we'll say it takes 5 seconds to fall. So 0 times 5 plus and 9.81 times 5. So let's plug this in again. Let's simple math here. So v is equal to 0 plus 49.05 plus 49.05. So if we plug that in, so the velocity is equal to 49.05 meters a second. That probably seems pretty fast because, well, that's fast. But let's plug this in here. So if you're in the United States, this would be in miles. So 49.05 times 3,600. And then you take, 176,580. We divide that by 1,000. Okay, that's pretty fast. How to find the velocity of an object. V equals U plus AT. Yeah. Huh. So, okay. So that's correct. It will end up at 49.05 meters a second. That is the fastest speed it will reach. That is the terminal velocity of the object. It still doesn't seem right, though. But it is. This is what the math says. So, let's say we need to find the height that it was dropped from. The displacement, in other words. So, velocity equals displacement divided by time. So, yes, we can also find the velocity like this. Let's say it was dropped. Let me clear this. So, let's say it was dropped from 10 meters up. And it took 10 seconds to fall. That's 1 meter a second, of course, because you're dividing that. But yeah, there's a bunch of formulas, and it's used to find the displacement, the velocity, you can find anything, because if you use math here, you have V is equal to UT plus AT. So you can move these around to figure out, let's say, the time that it took. So, let's say, move this around. So you subtract the V, so you have UT, you have U because you divide by T. So, yeah. No. No, that gets rid of the T. Yeah, you divide by 0. So you get V is equal to T plus AT divided by U. And then we have to divide by A. You get V is equal to T divided by A. No, I don't know. You can move it around though. Okay, that was the point. So you can move this around to figure out that stuff. So that's what this 9.81 meters a second squared is used for. So why is it squared? Good question. I really don't know. I've always wondered that myself, but I don't know why. But, yeah. So, that's a little bit about gravity. Oh yeah, I like this one. So fun. But yeah, that's a little bit about gravity. And what you can do with it. And a lot about Sir Isaac Newton, who got hit in the head with an apple, which sounds like it would hurt, but you know, I mean, I guess not, maybe. Maybe. But I would assume that it would. Okay, well, that is it for this video. So, goodbye, and thank you for... Wow, this thing is massive. And thank you for watching. If you enjoyed the video, please like it. And if you really enjoyed it, please consider subscribing. And yes, that is it for this video. So, goodbye.